Curtailable rates, primarily for our larger commercial industrial customers. We will notify the customer, usually by phone line or from some sort of a remote alarm device, that it's curtailment period, and he voluntarily reduces the load. That is opposed to an interruptible rate, where we'll have like an under frequency relay, such that if there's our generation is not matching our demand at the time, if you're under generating the frequency, we'll start dropping and it'll automatically reduce that load. The two different types of programs. This is an example of a curtailable operating day. This was for a particular customer. It happened to be a steel producer, and you can see upon notification, the blue line, he actually reduced his load considerably. I'm having a hard time focusing on the curve, but it looks like about 30 megawatts was dropped. I believe that's 40,000 to 10,000. Another type of innovative program that several utilities have been implementing is what's called a group load curtailment, where this is where a group of customers join together, jointly add up their loads, and agree that they will reduce as a group down to a pre-specified level. Basic schematic of how this would work: the utility is tied to the group through a computer system which constantly monitors that load, and upon request of the utility, a signal goes out. If one building for some reason cannot reduce its load on that day, the other buildings can work together to meet the group's firm service level that we've previously specified. It's a very innovative approach that gives the customer and the utility a lot more flexibility. There's reliability for the utility because there's strength in numbers, and the one building can't reduce his load, the other buildings can chip in. From the customer standpoint, there's more probability that he can get down to the agreed upon level. This is an example of an operation of my own company of a group load curtailment program, and you can see in the blue line the customer has dropped their load during the peak period of the day. Other types of, the last type program is the direct control program, where the usage is cycled. Either the load is shut off for a portion of the period or completely shut off. Generally, this is done with air conditioners and water heaters on the residential side. It's generally radio controlled. There are power line carrier applications or ripple, but generally FM is a predominant form of communication. And in exchange for that, the customer receives a billing credit. This is a agricultural pump. This is one of our newer programs where we're installing switches on agricultural pumps. And this has been successful so far. We think there's a lot of promise, a lot of potential in this area. This is an example of a commercial air conditioning program where the little device sticking up in the air is a radio switch that receives a signal and shuts off the rooftop units. And an example of a residential installation where you can see the installer installing it on the side of the residential air conditioner. Give you an idea of what the operation looks like. This is for a residential air conditioning program. You can see at the time of cycling the load drops back down, and I believe you can see the payback in there on the other side after it comes back on around 2100. Just a schematic of how the notification system works for direct control. From a demand control center, a signal would be sent out. It can be FM, it can be power line carrier, it can be ripple, received by the air conditioner. This is a fail-safe also in that there has to constantly be a refresh signal so that we won't shut an air conditioner off and it won't come back on. It has to receive the signal every 3 minutes. On any of our load management programs, some of the key results that are looked at are the dropout rate or customer acceptance. It has to be acceptable to the customer. The load impacts, we're expecting to get megawatt sort of combined impacts from these programs, and therefore there has to be a significant amount of load relief. It has to be cost effective to utility participant, and we have to have some people that are interested in participating in this program as far as recruitment. In summary, I think we're just beginning to scratch the surface on some of the distribution system efficiency improvements that we can make. We're really 10 years into the period of time that we started taking a real hard look at it because of the increase in the fuel costs. We've come a long way really in a short period of time. And I think one of the key things that we all have to remember is that by working together with our utilities, with our customers, and in like load management programs where the customer has to understand the utility operation, become better in tune with the problems of utilities, that it's an education on the customer part, and that I think in the long run is going to help us in the generation and the transmission area. So we're looking forward to a very interesting next decade. Thank you very much.
Thank you, Ron. Thanks very much, Ron. Are there questions for Ron on load management and distribution? Yeah.
How much resistance did you have initially from customers to the new project?
Well, it's interesting. We've done a lot of market research. I can speak from our own utility, and comparing results with other utilities, it seems to be running along the same lines. Many of the customers get involved in these programs because they want to help out. They want to do it for the public good. They're interested in just helping out. But what keeps them on the program is the economic incentive. Once they're on the program, they generally are inconvenienced somewhat. We can't deny that. Their house will get a little hotter. On the commercial industrial side, they'll have to take some action. They'll have to watch an alarm system or actually send people around shutting off loads. So it is an inconvenience. But we've had a very high success rate. The dropouts have been less than 5% on the air conditioning type programs, and maybe 10% on the commercial industrial type programs. So I think it can be characterized as low dropout rate, and customers really are interested in keeping those bills down, and they're willing to take a lesser quality service for that reduced rate.
Other people who have signed up so far, the people who tend to be the missionaries for energy saving, is it in other words going to be a lot more difficult to sign up the next block of customers?
Well, that's a very good question. It's probably too early to really tell. For example, on our own utility, we have on our air conditioning program, there are about 70,000 customers currently signed up out of 600,000 total, so roughly 10%. How difficult it is going to be to have the other 90% sign up, or whether we'd even want them to sign up, is something else. I think the real key here, we want to keep these programs voluntary. You provide the incentive. If the customer wants to take advantage of it, fine. If he doesn't, then he can pay the increased amount in his rates.
Ron, in Europe, I know there have been cases where programs like this have been started, the objective being to shift load into off-peak periods, with the ultimate result that the off-peak got close to being the peak, and the rules had to be changed at some inconvenience to the people that signed up for this. Do you look at on it? Are you worried about this? Do you see this as a danger in a program like this?
Well, I think the U.S. utilities are taking the European example to heart, and this is one of the reasons that we've gone as what you might say slow. Some of our regulators don't think we've gone fast enough, but we've argued that we do want to take a go slow, let's take a look at it, because we don't want to end up with the European situation where we end up with an evening peak that was higher than the peak that we started out with. I think because we are taking our time and going slowly in this area and really looking at it as an experiment, that we won't end up with that sort of a problem, but it's definitely something that needs to be considered.
Any other questions? Very good. Well,
Just one more.
okay, I'm sorry, I didn't see you.
Do you have any internal program to make missionaries out of your people that tell the public benefits of conservation? I mean, other than the commercial, is there any internal program to tell your normal employees?
Oh, you mean employees of our utility?
Yes.
I would say not. I would say that really we try to make the information available to them as we do to all of our customers. We have bill inserts which notify all of our customers of the programs as we go along. We try to make that information available to our employees. I think you bring up a valid concern that it's very important that our employees know as much as our customers do, because what we find out, because we have so many programs, that often the customers are paying more attention than our employees. And so when they're asked questions about a program, they sometimes don't have all the answers they probably should. And so we're trying to educate them on the program so at least they can communicate with our customers, not necessarily that they need to take advantage of the programs.
Any more? Very good. I thank you all very much. I'd like to thank our panelists. In fact, I think we ought to show our appreciation to them for preparing these remarks. And I'll now turn the meeting over to Alan Schell, who will make an announcement.
Thank you very much, and thank you, gentlemen. The electric power industry is vital to all of us, and I think these people have given us an idea of its vitality and where the directions it's going. That concludes this session. We'll have a short coffee break. The session on telecommunications will start.
Not even the stuff that's still lying around in
All right, yeah. Is that channel already all the way on? Wide open. You can kill it for the program. Yeah.
How does this work?
It won't be strong, but don't forget these people are going to be speaking fairly loud. Just right up like that. Believe me. It's the way it's done. Stop the tape. Beginning of the conference on technology policy, on U.S. technology policy, which follows this media briefing. That'll start at the entrance to the hotel, and there's a media bus to take you to the finish line in case you don't beat the runners. And so keep that in mind, and we'll try and conclude on time. This session is on telecommunications, and this has been, the past year has been an epic one in telecommunications. I think you're all aware of that. It is also an area of electrical and electronics engineering activity that pervades our entire society. And all those aspects dealing with computers tie so closely into the means of communications between users and those information processing devices. I think this session will really enlighten you on that subject, and I'd like to introduce, as the moderator for it, Dr. Richard Van Slyke. Dick? Thank you.
Okay, first some logistics. We try to get the people that are actively working in the fields. One penalty of that is sometimes something comes up and they have to get the work done. Such is the case with Larry Rands, and we got his boss here, Bill Mayo, to discuss the NBC satellite project. Another bit of logistics is there's some inconsistency between my introductory remarks reproduced in the handout and the order of presentation given in the schedule. I'd like to go in my order. We'll have Howard Frank first, Bill Mayo second, and Rick Gould third. And the last thing is I have copies of a bio for Bill Mayo, which I'll start around the room now so that you know who you're hearing when the time comes. Well, there's no lack of news about telecommunications these days. There's so much, in fact, that an overview in a session of this length would be impossible. So in organizing this session, what I did was pick some topics which are interesting to me that I'd like to learn about and gathered together experts on those to have them speak about them. The first topic has to do with the divestiture you've been hearing so much about. I don't think there's anybody in the field of commercial telecommunications that doesn't think it's in a extremely chaotic state now. A lot of it seems to be blamed on divestiture, and a lot of people sort of characterize divestiture as a gratuitous act by regulators, legal people, and the FCC to mess with something that's working and make it not work. I was sort of curious as to whether there are other more fundamental forces at work, and I think Howard Frank will address that question. The second thing that I was curious about, and I hope you are too, is that also as part of the divestiture, there's a lot of discussion about access charges and the possibility of bypass by large corporations of common carrier facilities, telephone facilities. And there's even a question of how often that will happen and what are the circumstances. A rather extreme example of bypass will be discussed today, where NBC virtually moved its whole network up into satellite, and Bill Mayo will talk about that. The third thing that pricked my interest was the plan by the United States to possibly leave UNESCO, and some of the reasons advanced for that was the so-called New World Information Order and the politicization of international bodies. Many of these same issues arise in the International Telecommunications Union, in particular with respect to access to the spectrum and to geosynchronous satellite orbits. A person that's been involved in these negotiations and problems for some years is Rick Gould, and he'll talk some about those issues. So those are the questions we'd like to look at, and I hope they're as interesting to you as they are to me. The first speaker is Dr. Howard Frank, who is the President and Chief Executive Officer of Contel Information Systems. He's a fellow of the Industrial Engineering IEEE and is a long-time participant in the process and developer in the process of designing very large networks, and I'll let him speak to you on the first issue. Howard.
Thank you, Dick. I was struck this morning when I was listening to one of the speakers on electric power by a comment that he made saying that the last 10 years is a relatively short time to get any predictions or trends. And the second thing which struck me was the motto over here, a century of electrical progress, and putting that into the telecommunications field, all that happened in the last 10 years. sort of in the telecommunications field, a lifetime has been lived both by the individual participants and by the technology in just the last decade. I think the most important part of what I'm going to be saying is that if you take away the divestiture, and if it had never happened, the field would have been heading towards chaos and crisis. There are many, many different pieces of evidence that point to that. When you add the divestiture on top of that, the potential chaos in the field just accelerates. And what I'm going to be doing this morning is stepping through some of the things which lead me to that conclusion. I'm also going to hope to suggest a few ways that we might avoid it, but I think that all of the steps that are needed to create this crisis are already in place, and it will take Herculean efforts to avoid that. Okay, so first of all, let me step back 10 years ago. Telecommunications was very simple. Telephones tended to come in different colors, but if you wanted to buy a PBX or a telephone, you got it from the telephone company. A telecommunications manager's life was basically ordering lines, ordering handsets, picking the colors, determining the number of buttons on the phone, how many lights should be on the phone, things like that. A data communications type person spent his time in designing large networks which might have had 300 terminals, 2 or 3 computers, and covering a state or even possibly the entire United States. If you just step into today's world, you notice a few interesting things. A couple of years ago, I was at a PBX manufacturer's facility and reviewing his plans for a new generation of PBX. And I looked at what they were doing in the telephone handset. And there was a brilliant piece of technology in the telephone handset involving a piece of what's called delta modulation, computers, and the integration all into a microprocessor in the telephone. I thought that from a technological point of view, it was a marvelous innovation. But then I realized if you picked up that handset and carried it to a different building with a different manufacturer's PBX, it wouldn't work. That's a remarkable statement because if you think about the progress of the field of telephony in the last 100 years, which is basically how old the field is, the one thing that we've become used to is the fact that things tend to work independent of geography or location, and a telephone set in New York is the same as a telephone set in California, and so on and so forth. In the last 5 or 6 years, with telephones being computerized, we've now degenerated or begun to degenerate to a condition that the computer field was in about 10 or 15 years ago, where a new terminal was introduced. It was incompatible with all the old terminals. It was incompatible with all the old applications. And in fact, nothing worked with anything else. And the computer field has been working to climb out of that hole, not successfully yet, for the last decade, and will probably take at least another decade before it does that. We are just stepping into that piece of chaos right now in the telephone area. Another thing that struck me just a few weeks ago was I was reading an issue of Consumer Reports, and it had a section on telephone comparisons. And it made a comment in a rather blasé way, as if this was a natural part of life, that telephones now would, if you bought them from other vendors than AT&T, have a lifetime of on the average of 2 years. 2 days later, I just happened to get in my mail a new telephone bill, which said that if my telephone breaks, well, I could do this, but if my line went down, I could do that, but if I couldn't figure out which it was, I could do something else. And oh, by the way, if I did the wrong thing, it would cost me $200 for a service call. We've gotten used to telephones working because they were designed to last for 20 or 30 years. We've gotten used to an end-to-end service which, independent of what anybody says, has been quite good at virtually everywhere in the United States. And we have now introduced an element of failure and disrepair into a system which nobody is ready to cope with yet. That all happened on January 1st. But things that were happening before January 1st have also been in a very strong movement towards failure and breakdown and potential chaos. For example, I'm sure most of you have heard the term, my PBX is down. 10 years ago, I hadn't heard that term. If your PBX went down, that was a monumental failure because your entire telephone operation was out of communications with the outside world. Well, my PBX has been down about 17 times in the last 3 months, and more disconcerting than that, a piece of it may be down at any one time. And some days call forwarding falls off, and another day something else falls off. And the root and cause of that is quite obvious. The PBX now, instead of being an electromechanical piece of device primarily, has now become a computer. Computer failures have been with us for as long as computers have been with us. And the state of the technology of computerization is such that failure is considered to be normal. And in fact, a system which works 98% of the time is a highly reliable system. While a telephone system which works 98% of the time is a highly unreliable system. We've now inherited all of the major problems that have come out of the computer field which have not yet been solved and won't be solved for a number of years. Third factor, which I think is very significant, is if I step back just a very few years, when people were building complex telecommunications networks, they were talking about connecting up a few hundred, 500, maybe 1,000 terminals to a computer, and that was considered to be a gigantic network. Today, when people talk about large networks, they talk about 10,000, 20,000, 30,000 terminals. But the technology of keeping these kinds of systems running has not changed very much. The fault diagnosis, repair technology, the automation of human procedures to identify where failures in a network occur has only occurred at a linear process, a linear growth rate. Most systems don't have those kinds of capabilities yet. But the size of these systems has become so large that failure in some part of the network is a constant, sustained, continuing part of life. And our technologies for improving that have not yet occurred. Now, another element of that is a week and a half ago, I happened to be attending a meeting in Boston, and somebody had come from another meeting that morning and said to me, would you believe that an organization, in this case a large bank, is planning a network which will contain 15 million terminals? And so I quickly wrote that down as part of the text of this talk, because I wouldn't believe that, but apparently it's happening. Every personal computer in the world is going to be connected to this network if their marketing works. Okay, if you think those things are bad, we're just beginning, because in the field of technology, we discovered a very wonderful world called integration a few years ago. And integration means many things to many people, but in the field of telecommunications, it means putting more than one kind of function or service into the same system. So we now have integrated systems which carry office-type requirements and data processing type requirements and telecommunications requirements. We have vendors who started out in the data processing field who recognized 5-10 years ago that telecommunications field was going to be very important and started moving in that area. We have telecommunications vendors who discovered data processing. We have office automation areas, vendors who were making typewriters, who all of a sudden were making DP systems, who all of a sudden are now making integrated systems. And we had vendors who supplied boxes who discovered that what the marketplace wanted was systems, and so therefore started offering software and integrated solutions. Each of these vendors is trying to sell function from somebody else's natural field. Many people are buying these things, and the one common thing among all of these is they tend not to work very well. The brochures describing them are beautiful, though. Okay, now adding to that is a problem which I consider the single major problem of the 1980s and the 1990s, which is the area of education. If you open the New York Times on a Sunday morning in the business section, and you do that for about 4 or 5 weeks in a row, you will be struck by one fact. You will see identical ad after identical ad for the same kind of people, usually from the same company who can't recruit those people. The telecommunications field has had a gigantic growth in requirements of people, but there have not been a corresponding growth in the production of people. Now, what happened, I believe, is that the university system in the U.S. has failed abominably to meet that requirement, and has failed to understand that the telecommunications field of the 1980s was different than the way it was in the 1960s. In between that, since industry is quite innovative, a number of courses and companies sprung up to offer these short 3-day courses, which take people who basically know nothing about the telecommunications field and create instant experts. The three-day courses turns you from an amateur into a professional, and then you're placed in charge of a multi-million-dollar telecommunications system. Many times, the managers of these systems can't tell the difference between a modem and an Erlong. I know people in the press are not supposed to know that, but if you've taken a reasonable course in telecommunications, you should. This problem seems to be getting worse as opposed to better. There are a few organizations, for instance, Polytechnic Institute of New York, that is trying to do something about it. Professor Van Slyke is leading a program in that area. There are 2, 3, 4, 5 others. But basically, the university system has been completely silent in regards to telecommunications education. My son, for example, is studying electrical engineering at a local university in Washington, D.C., and I looked at his junior level curricula, and it's close to identical to the one I took in my junior year. Now, to just display my age, I took that in 1960. He's learning the same kind of circuit theory that I learned in 1960. In 24 years, I never applied that circuit theory, but he's still learning it. Nothing in his curricula has to do with telecommunications. Add on top of that the divestiture, which has had 2 or 3 different kinds of impacts. At a metaphysical level, the impact has been that if you happen to be in the telephony industry, you don't know how much money you're going to make this year because of congressional legislation which may or may not occur. If you happen to be a large user of telecommunications, you have no idea how much your bills are going to be because the tariffs tend to be rejected and resubmitted in different form. But if you are trying to run a telecommunication system, you don't know whether your lines are going to be there tomorrow. Now, it's nice to speak from experience. In this particular case, I'd rather have not been speaking from experience, but let me talk about a specific instance which happened in my offices in Great Neck. We put a change order in November of 1983 to fix a Watts line of a dozen or so Watts lines terminating in our building. In January of 1983, all of our Watts lines disappeared. In February, all of the people who had been working on our problems disappeared along with them. Now, it sounds great unless you're trying to make a telephone call out of Great Neck, New York. As far as I can tell, that's not an isolated phenomenon. It is happening all over right now. The operational chaos coming out of the divestiture hopefully will die down, and the more fundamental problems will begin to arise again. But now, combined with the people shortages, the equipment problems, the technology problems, the complexity problems, and so on, we're reaching a point where the entire field of telecommunications can suffer a gigantic collapse. In the early 1970s, if you happen to be a data processing manager running a large batch processing center, you went through a period where nobody believed anything you would say, and nobody would give you any more work, and your budgets got cut, and users started moving away from that central data processing center because they had been no longer capable of doing the job. We're reaching that same kind of point now. There are too many factors going on. There are too many conflicting requirements and changes, and telecommunications managers are typically not capable of dealing with them. We also have one other factor making the problem even more complex. That is, in most organizations in the United States, the structure to deal with the problems is not appropriate to the level of the problems themselves. We have different data processing departments, different telecommunications departments. We have office automation people who are growing up in possibly an administrative area. We have different lines of reporting. We have two kinds of political battles going on. The political battle between those different departments for ascendancy in the integrated world, and we have another family of battles that are going on between the corporate type staff who want to capture a centralized type of resource and the division staffs who want to maintain their resources to meet their unique missions. So you take all that, and there are some troubles coming. Those troubles are not necessarily avoidable, but they can be at least mitigated by some awareness. And I think that's the first step, that the press, senior management, people in general have to become aware of this maelstrom which is brewing and at least get some tolerance levels that are up. Second, as quickly as possible, we have to try to stabilize that post-divestiture environment. And, for instance, congressional actions right now are destabilizing effects as opposed to stabilizing effects. The procurement process has to work better. There has to be a lot more careful planning and education. But primarily, in the longer term, I don't think that much is going to save the problem unless we get universities and government and organizations like IEEE to start recognizing that there's a serious educational gap. And that educational gap is going to have to be solved before we get out of this potential disaster. And that's the final point that I want to make, that an organization like the IEEE, in conjunction in particular with business and the university systems, can do a substantial amount in trying to solve now the long-term problem. And the longer-term problem is not going to be solved in 2 days or 2 years, but hopefully if solutions start being implemented now, by the 1990s we'll be out of that hole. Thank you.
Any questions for Dr. Frank?
Could you be a little more specific on the kinds of cooperation that you just suggested between IEEE and business? I mean, what kinds of things do
we need? Educational programs. For instance, after this session, Dick and I are going to go off and we're going to talk about how Contel Information Systems can start funding a program within Polytechnic Institute to get some joint education. I think we have to recognize that education, which is usually the first thing which gets cut in a down type economy, has to be the last thing which gets cut. I think people have to recognize that time off and an intensive effort to really educate telecommunications people is mandatory, not just desirable, and that the educational standards in the field have been decreasing significantly over the last few years. I mean, it's incredible what people are now considered to be experts in this field. It's understandable because there aren't enough other people who really are knowledgeable. Money and resources. Business can provide the money, the university systems and IEEE have to provide the resources. The only people who can do that tend to be in industry right now. What has happened is a quite natural attraction to industry because of the high salaries compared to universities of most of the knowledgeable people in the telecommunications field. So I think we have to have not only contribution of money, but people coming from industrial environments and with time off to teach either one course or 2 courses, but certainly a cooperative effort. There aren't enough people at the university systems who are knowledgeable enough to really handle that problem right now.
You indicated actually also standards. Would you say it has the highest priority, standards or education?
Education. Because in the long run, we won't climb out of the problems without it.
Okay, what do you think should establish the standards?
I don't think that you can change the university system. Universities who grant degrees should be establishing the standards for those degrees.
Standards for telecommunication hardware.
I'm rather pessimistic. There are a number of standards organizations. They tend to take decades to work, and I don't believe that they can be accelerated. There are too many vested interests in not having standards to make those things move very quickly. For instance, if you, just as an example, the X25 standard, which was approved about 1975 after work on it for about 5 years, is only now becoming a significant factor in the telecommunications field, and it'll probably be 1990 before most vendors are compatible with it.
If you look at the technologies that have come on in the last 10 years, fiber optics and satellites and digital integrated systems, networks, and all the rest, it is very much, like, as you said, like the computer industry over the last 10 or 15 years, these quantum leaps in technology. And I'm just interested in your comments on the incompatibility of telecommunication systems now. As you say, you can't take a phone from one PBX and use it in another. And yet I wonder, is that any different from what has ever happened in any kind of an industrial or a technological revolution, that there are suddenly a plethora of great things that come on stream, and then there's a shakedown, just as there was in computers, as there is going on in computers now. Why isn't it that the cream will rise? Why wouldn't it be that the Bell Labs or the GTEs of the world, or some new entrepreneur will come along with some way to make all these terminals, these telephone handsets compatible just the way an IBM and an Apple are compatible now?
So I agree completely with all your comments. I don't think that it'll be that simple that one new technology makes them all compatible. But during a shakedown period, I hate to be the one that gets shook down. that we are in that period, and will be in that period for the next decade or so in the telecommunications field, if not longer. And the way of avoiding it is to have one dominant vendor, which we're trying to move away from. IBM, for example, set some standards in the middle 1970s by introducing a system called Systems Network Architecture, and that did set a de facto standard. And for the last decade, people have been trying to become compatible with that with great difficulty.
If you could look 20 years into the future, do you think that the telephone that we have today will be very much synonymous with a computer terminal?
Yes, it'll be an integrated telephone data terminal. I don't have to look 20 years in the future to see that. I can look 2 hours into the future, because there are products on the marketplace now that do that. Within 3 or 4 years, they'll be beginning to proliferate, and within 20 years, they'll be standard. If you look at some of the...
Where a home will have a phone...
Absolutely.
It will have a screen and...
Absolutely. All the technologies are in place right now, so I don't have to go 20 years to expect that. And if you look at some of the things that are happening in Europe with directory terminals and so on, you could justify terminals in people's homes now on the basis of offsetting costs of labor. For example, in France, one of the goals is to have these directory terminals, and at several $100s a piece. Apparently, the payback period is 1 year to 2 years. So it's remarkable. And technology, of course, in large-scale production will make those numbers actually even smaller.
Considering the complaints that are beginning to filter out of Bell Labs, I noticed that you did not mention as one of the worries that you have the telecommunications research segment of the telecommunications industry. Are you now worried about it, or did you just not mention that?
I am neither worried about it, nor did I mention it both. The one thing that we have plenty of is innovation in this field. A bit more than we can actually absorb right now. I really don't see that as a worry. It is easy to invent in this field, because we're at the beginning of a field. 25 years from now, after all the things that can be invented have been invented, it'll make a little bit more, maybe be more of a problem. But right now, we're in the area where virtually every place you look, there's a chance to innovate.
You were talking about incompatibility before. I'm just wondering whether the development of chip-based conversion schemes, maybe that's not the proper technology, but I think you know what I mean, whether this reduces the seriousness of the problem.
It could, but I think that'll be the second stage after the problem gets even more serious. You see, the invention of the digital PBX is a magnificent thing. It's a neat device. It does a lot of things that are very good. Unfortunately, everybody's scheme is different than everybody else's scheme for digitalization. And when you put that in the handset, until you have gone through the generation, or maybe a generation and a half of those systems, and the compatibility problem becomes worse and recognized, people are not going to start solving it because it costs money.
Can't see it anymore?
I may have misunderstood you, but I thought at the outset that you said that without divestiture, this plunge into chaos would be even worse.
No, what I said was divestiture makes it worse, but without divestiture, it would still be here. Divestiture right this second is probably the single most immediate problem that is driving this, because of the fact that if lines disappear, they've disappeared. But that all the trends have been in place now for a number of years for this chaos, and it would be occurring anyway, except divestiture allows us to take another look at it and recognize it for what it is, but not to blame it on divestiture.
Are you saying divestiture was a bad idea?
Depends on what time frame you're looking over. Okay? If you happen to be in Great Neck, New York, trying to make a telephone call, it was a bad idea.
Long term?
Long term, no, I think it was a good idea. Where long term, hopefully I will live that long. Okay, thank you.
Well, after that cheery, upbeat assessment of the telecommunications field, we'll move on to Mr. Bill Mayo, who is Vice President of Satellite Systems at ComSat General, and he'll talk about a satellite project that they're doing with NBC.
Yeah, somebody's going to do that, I guess.
I too hope my fellow panelist lives that long. I'm going to show you just a few slides that describe what we're doing for and with NBC, so that what we talk about is a little bit less in the abstract. I have, in the course of trying to evaluate what it is you'd like to hear, thrown away a few slides that we could go back to if it needs some elucidation. But let me just show you first that what the NBC satellite television distribution system looks like. Each of the dots on that particular map, regardless whether they are blue, red, or yellow, represent an NBC affiliate or owned and operated television station. And the purpose of the system is to link all of those stations by satellite, so that essentially all of the landlines over which NBC has done its transmission in the past are eliminated. There are two master stations there, the red dots, which you may or may not be able to see, located in Burbank and New York. There are, on that particular map, 8 yellow dots which represent potential, or not potential, but very capable uplink sites which can feed the network, as well as the stations in New York and Burbank. The whole system is controlled by a very sophisticated computerized system. There are 2 antennas minimum at each location. They are pointed automatically. The receivers and transmitters are changed automatically. The whole thing is a very highly sophisticated computer-controlled system. The ground segment, those little dots that you see, add up to the equipment complement which you see there described as ground segment. 2 masters, 8 transmit receives, 150 protected receive-only stations, 37 and so forth. You can read that as well as I. You will notice that the absolute minimum capacity in the system is 2 channels at each of the receive-only sites, which is the least capable of all the installations, with a 3rd receiver as a backup in the event of failure of the others. Okay. The space segment consists, for the purpose of serving just the NBC distribution needs, 4 full-time transponders, 5 to be used on the weekends, the so-called occasional use kind of thing, which is for football games and the various other sporting and news events. There is an additional weekday transponder available for fast-breaking news events and requirements that might go beyond that. They are all on satellite owned by SBS, which is one of ComSat General's investments, as I suspect most of you know, is the 3rd satellite in the SBS constellation. And there's one very interesting thing there that sort of addresses the technology of the NBC system, and that is that we did what we think is a pretty clever thing. In order to get higher power on the satellites so that the ground segment could be somewhat more economical in terms of using smaller antennas, for one thing, we paralleled 2 of the tubes, the traveling wave tube amplifiers that provide the output power for the satellite, and in so doing simply doubled the power. That's the reference there to the high-power transponders, which have not only been tested. This slide is getting to be a little bit little old at this point. They not only have been tested, but they are in use. 25 stations are currently in operation in the NBC network, being fed solely by satellite. The balance of the stations, all 183 as it totals, will be on the air by about the 1st of October. The network management system, which I mentioned, the computerized control system, does all those things. It controls the network configuration in the broadest sense of that particular term. I won't dwell on that particular one. Now we go into the pretty slides. One of the features of the whole system, which is particularly attractive to the sports and news type people, are the transportable earth stations, one of which you see there folded and in its drive-away configuration. Now we'll see one of it, the antenna being deployed. It's made roadable by the fact that the antenna is broken into 3 pieces, as you can see there, which fold as pedals with little notches that there's a slide-in panel that automatically comes out so that it does not destroy the feed when it closes. The whole thing is hydraulically actuated and deployed, and that it is capable of feeding the network, and in fact at the moment is feeding the network, 2 redundant transmit channels, and capable of being erected in about 20 minutes after it arrives on site. Next one, please. And the last pretty picture that we have is a picture of the first satellite man has ever seen being launched from anything except the ground. That's SBS-3. Most of you have no doubt seen that picture already. That really and truly is an honest-to-gosh picture, not one that was phonied up, of the deployment of that satellite, the first commercial satellite to be deployed from the shuttle. And that's the end of the pretty pictures. Now to go into a little bit of the reason for this whole move on the part of NBC and ourselves. I would like to tell you that it was a very far-sighted thought about bypass, but it really wasn't. The bypass issue as an economic issue has only arisen generally in the last couple of years in terms of widespread attention. We in NBC intended to bypass, but not for economic reasons. That was a secondary one. The purpose of this whole effort is to provide a very direct and very flexible communications channel that in fact provides better quality and better availability. Availability meaning the dependability of the system than they had before. The ATT system has done a very outstanding job of providing service to all 3 of the television networks. It is not quite as good as they will get on this, and it certainly doesn't have the flexibility. For essentially the same price that they were paying to AT&T in the past, in total, they will get 4 times the transmission capacity. And that's an economic advantage not to be overlooked. They will, yes, bypass the local loops. All of those antennas are located on the site on the premises of the affiliate station, be it his transmitter or be it his production facility, and it varies from one to the other. I have some pictures there that I pulled out because I didn't want to take your time of some of those installations on rooftops, a lot of them in parking lots. The important thing is that because the system is designed, or the system has as its very lifeblood, a frequency band called KU band, which is a higher frequency than has heretofore been used for commercial purposes. There are not interference problems so that the antennas can be located in the middle of very congested areas, unlike the C-band or lower frequencies, which currently are in use in most locations, and the channels of which are so congested that it's virtually impossible to clear new sites. Bringing the signal straight from whatever the uplink site might be directly to the affiliate's location is a very attractive financial advantage. It is a bypass. It does provide a kind of availability and dependability that heretofore has not been achievable. And that's really the whole thrust of the system. I could go on at undoubtedly terribly boring lengths about the technical advantages, what has been done in terms of advancing the art. I think that probably is inappropriate. There is one additional fallout which I will mention before I stop and listen to questions, and that is that when we started this whole program, because of the fact that KU band equipment, this higher frequency band stuff, had a relatively small market in the country, the price of acquisition as compared to C-band was about twice, a factor of 2. The price that we paid for the equipment to do this program for NBC is about a 10% premium over C-band, and that's purely and simply because of the production volume which was achieved. The equipment is ours, by the way. This whole thing is leased to NBC. They do not own a single piece of equipment that's related with it. It's a long-term contract, 10 years, in which we will provide the service. And it is only because of the advantages that one gets from significant volume production that financially it was a doable kind of thing. One last word. If you remember the map that showed all the blue dots, those dots and the associated capability to reach those particular stations cover something in excess of 90% of the population of this country. We're kind of proud of the fact that that is the second largest long-distance network in the world, second only to AT&T. And clearly there are many things that can be done with it besides television distribution. End of story. Sir.
What's the general outlook for the availability of satellite channels over the next several years?
Well, there are about as many answers to that as there are to people who are asked the questions. There are people who ask the question. I don't believe that there is going to be any significant shortage of transponder capacity near term. I assume that that your question is partially, at least, generated by the failures of the last 2 satellites. There will be people with particular needs, somewhat more unique or specialized needs, who indeed do find some difficulty in acquiring transponder space, but generally I think to take care of most things there will be enough. Sir.
It's my understanding that the KU band has some technical problems with atmospheric or weather interference, that the signal tends to disperse in rainfall, for example, or through clouds. How has ComSat overcome that problem?
Well, that's a correct understanding. It is true of all electromagnetic waves. As you go higher in frequency, they are more attenuated by precipitation and atmospheric effects. There are ways to offset that. And one of the reasons, by the way, that we are comfortable with KU band and staking a guaranteed performance for long periods of time on it is because When we launched the ComStar series of satellites in 1976, we had on them radio beacons operating at around 20 gigahertz as opposed to the 12 and 14 gigahertz range of KU band, which were there for the purpose of propagation studies to be done in cooperation with AT&T, GT&E. We gathered so much data out of those satellites that we finally turned them off. But the purpose, or turned off those beacons, not the satellites, are still in service. The problem of attenuation at KU band is indeed there, but it is soluble, and that's the primary reason for doubling the output power of those transponders on the satellite, which I described earlier. One can cope with it by either increasing the output power of the satellite, or by increasing the diameter of the antenna on the ground. And what we did was reach a happy medium in there, and the projected availability in all cases is above 0.9999 based on the rainfall models and predictions of what the attenuation would be. It's a question simply of recognizing that it's there and designing to cope with it. Yes, sir.
I'm wondering about the possibility of lower cost on-site satellites over the next few years. Hughes, among others, I believe, has proposed to the FCC a satellite that is much more powerful than those already in service. And one benefit of this satellite will be to permit much smaller diameter ground stations, which I believe would be much cheaper than what's on the market today. Could you talk a little bit about this development?
Sure. There is a crossover point someplace in the power race, and there are at least two separate and distinct schools of thought on how that should be done. I assume that it's fairly clear what school I belong to by virtue of what I have said about paralleling tubes and whatnot. That, however, is a technique to get to a particular output power. The problem with continually increasing the radiated power is that the spacecraft must ever get heavier and larger in order to carry a power supply sufficient to do that. And someplace in there is an economic crossover point.